Okay, you're going to want to make sure you have a nice, good amount of space. This takes a little bit of work. And listen, this is one of those, like I told you way back in October. If you don't follow my notation, I am not helping you. Because it's just too complicated for me to have to figure out whatever the crap you're doing. Okay? Like, you've got to follow my notation. So here's where we're going to do the work. It's like straight down this page right here. But over here we got to do some scratch work. So you look at the problem. Now follow my logic. You look at the problem. You say the pink sheet does not fit. So my next best hope is use substitution. I'm going to teach you a step-by-step method. Once you get good at use substitution, you kind of can forget the step-by-step method. But starting out, it's really hard without some steps. So your first step is to recognize that what you see is two functions being multiplied. That's why it makes sense to think of it as the reverse product rule, even though it technically isn't. So I'm going to rewrite this. Well, I don't really have to. I can just see it. I've got this times this. Two functions being multiplied. There's a few exceptions, but generally, if you don't see two functions multiplied, you cannot use substitution. Like I throw out the word that we'll see an exception once in a while, but it's very rare. If you don't see two things multiplied, you can't use substitution. So, good so far, two things multiplied. Okay, the two functions that are multiplied must be of the following type or form. One of them has to be something to a number, or perhaps actually one or both can be any of these forms. Okay, now this notation is, you're never going to see this in a math textbook. You're never going to have another teacher probably show you this kind of notation. This is just my common sense way of communicating what you should be thinking. This formula right here fits this perfectly. This is x to the first power. Therefore, the something is x and the n is 1. This one fits perfectly as well. The something is 4x squared minus 3. The exponent is negative 4. So that fits this form. In future problems, you'll see this form as well, and this form. To make things easier to memorize, just look at your pink sheet. The 5 formulas down the left side of the page all follow this general idea. Okay? The only difference is the pink sheet is specific. When you're doing use substitution, you can be generic. Just something to the end, not just x. You good? Please.
Does that mean it could be something to the n minus something, or does it still have to just be a single exponent? Like for the pink rules, it's not allowed to be x to the n plus 1. It has to just be x to the n, or else it doesn't work. Is that the same for this?
I'll say yes, but I have to sit and think about it, see if there's an exception. 2 points. Maria, please.
Okay, so you said both types have to be at one of those.
Yeah, so you're going to see two functions being multiplied. The two functions will always be of one of these 5 forms. 2 points. Okay, the next step. It's called use substitution because we are going to write down the letter U. That's generic. You could choose any letter. It doesn't matter. I like using the letter U because it makes this discussion more interesting, because I get to say very clever things like, well, I'll show you in a minute. It will. It sounds better as we get going. So, U here, the choice for you, see that sounds good. Choice for you. Yeah. The choice for you, it's more fun. Okay, the choice that you will make to choose U, see, it's good to use U because it's more fun. Kind of are smiling. Okay,
I like it.
look, the choice of U is always the something. So over here, this is something to the first power. So a possible choice for U is to say U is going to equal X. I also like to have English teachers in the room because it's like painful for them. The grammar sounds horrible. Right?
U is X.
U is going to be X.
Okay, so
because u is going to
When you say you write u is equal to, and then you choose one of the two, it's just simpler to use the x in this case, but could it also be the parentheses 4x squared minus 3
You, again, a few exceptions, but generally you have two choices for u. And both choices are the something as defined in the functions.
How can u equal both of them?
No, u is going to be one or the other.
You just chose.
You have to choose which one. So it's like the Raiders of the Lost Ark movie where he says you must choose wisely.
Okay, so
So this,
it usually will only apply
Nobody's
to
seen that movie apparently. Go ahead.
the top left one of those things that we did.
What you're doing is you first start by saying I have two functions being multiplied.
Yes.
They've got to be of this form. That's what helps you identify what the something is. So I've got two possible somethings. Something to the first and something to the negative fourth. That means you could be either something.
Oh, okay. So if one of the functions was cosine of something, then u would just be the something
The
that would
something.
be the cosine.
U is always the something.
Oh, okay.
It was at this point last year in A2 that Mikhail Dahl and Eli Lysenko remembered the scene from the movie The Help, which is a really good movie. And they made me a nice sign over here. U is smart, U is kind, right? U is important, U is 4x squared minus 3. U is really something. U is something. That's good. That's a good sign.
oh, okay.
Promise, Nicolette, it'll be all right. Look. Gosh, gosh. Oh, sorry, David.
To the fourth, like why is it only what's in the parentheses?
Gotcha. I'm going to give an answer. It's probably not going to be very satisfactory, but be a little patient.
It cancels.
Give me a ticket. I got it.
You're lucky. Okay. Look. Okay, we're learning the technique of doing a U substitution. For the purposes of our class, we really don't have to know why it works. We just have to know how to make it work. So I don't have a great answer for you other than to make the process work, we always choose the something. So U is always the something. And this function is of the form something to a power. Something to a power. My choice of U is always just the something. Just the something. Now there could be examples, Danny, like this, where I'm not saying you'll encounter this, but it's possible, where you had something like this. Okay. Well, this is cosine of something. So now the something is all of that. You see the difference? Does that help? 2 points.
Wait, does that mean if one of the functions that we're using as a U substitution is 1 over the something?
The whole thing. Really good example. Really good example. 1 over the something is whatever's this, all of
If
it.
it was 1/2, then it would be just. the
Yeah,
two.
1/2's a constant, so not likely.
1 over x, it would just be x.
Correct. Always the sum. Just remember the movie, it helps. U is something. U is something special. So, yeah, good. Are we good? That's a really good movie. Yeah, it's really good. Like, way good. I watched that 100 times before I go watch another Avengers. Avengers is fine. Avengers is fine. Avengers is fine. But I just prefer a movie like The Help because I just like the story so much better. Because that's much more mean. Avengers is that great entertainment, you know? Sorry. Sorry. Like I've seen all those movies. They're not memorable. That was good. Okay. Woo!
Wow. That's a lot.
not memorable.
Exactly. Just action. Fight upon. Like, where's the story?
The story's in the kiss at the end.
Moving on. Quiet. Okay, look over here. Okay, you're never going to make this pick. Because changing you to, like, switching you, and remember, equal means these are the same. So we're getting ready to make replacements. Well, taking this problem and taking out an x and putting u in place of x everywhere doesn't change anything. It just looks different. So that is, dumb joke, useless. Okay, don't ever do that. Got it? So this is the correct choice, I hope. Here's how I find out. Remember, it's what I was talking to Adam about. The dx is important because antiderivatives and derivatives are connected. So there's a dx here. So when I go to take a derivative here, I've got to do it in terms of dx. So you write d over dx of this half of the equation, and then you do the same to this half. You're using the equal sign. Question?
So then you have to like use another variable and then make that like the x.
No, because this is d dx. You know, like, ignore this for a minute. Like, I get that you don't know what to do with this, so just write it down. This is no different than this had said f of x equals. You'd say d of f equals this. This side you know what to do it because you have the green sheet. Like, what gets written here? You all know. Come on, what gets written here? 8x.
Wait.
Please.
So if you change the u, if you change x to a u, what do you, with the ending of it d of u instead of d of x?
Yeah. 2 points. Anybody else? That's why it doesn't change anything. You good? Come on, focus. It's okay, I promise. Next step. Okay, this is an indication that everything is going to work because I started with two functions being multiplied. Fair? I identify the form of each function. That allows me to pick the something as my choice of u. Now I take the derivative of my choice. Okay, my choice came from this. You know, this of the two multiplying functions, my choice came from here. The derivative of my choice must be the other. Other than you cannot worry about multiplying constants. So the 8 I don't care about because it's just a multiplying constant. This always gets factored out anyway. Hey, it matches perfectly, x and x. When that happens, you know u substitution is going to work.
So when you use u substitution and do one of the factors and take the derivative of that, it's supposed to be the other one?
Yep. Kind of. Like, the words you got to be a little precise with, but I'll just say it again. You start with two multiplying functions, correct? Okay. By looking at those two functions, you can come up with two possible choices for u. U being the something, right? Yeah. You take the derivative of your choice. This derivative must be the other of the two multiplying functions, excluding the fact that this is 1x and that's 8x. We don't care about the constants that are multiplied.
If it doesn't work like that, then you just can't do the problem.
Right, so u substitution won't work every time. For our class, what's going to happen is, if it doesn't work, it means you probably should have just used a formula and didn't notice, or there's an algebra trick that you're going to have to use instead. We won't worry about the algebra tricks today. So there's no other possibility for our class. It's either the rule, u substitution, algebra trick.
So it's never going to be like, you need more information.
No, they don't ever do that. They never have, so. Ever. So I don't think they will.
So how do you use like correct notation for u substitution?
Just what you see here. All of this doesn't really matter. This is just your scratch word. The correct notation is here. So now what happens next is this. You say, okay, I'm going to put a u right here because 4x squared minus 3 is u.
Do you have to state that?
No. If you can do the whole problem in your head, they will not deduct points.
If it's on the multiple choice.
Not even in the FRQ.
So you don't have to, like, before you would have to state, like, end of X.
No.
You can just,
You can just do it.
okay.
All of this work, Jackie, is because I have not found one student out of 1,000 who can do this in their head. So I think you need to write it down. Does that make sense? Please.
I'm just a little confused because we were using x is equal to u. Do I plug it in for the other stuff?
No, we thought this might work, but then we said that won't help at all. It's useless, was my dumb joke. So we don't want to do that. We're doing this one.
Okay.
So I've taken away the 4x squared minus 3 and replaced it with its equivalent, which is u. So these two functions are being multiplied, so the order doesn't matter. Okay? Now I look over here, and I notice du over dx literally means du divided by dx. So algebra says I can multiply both sides by dx.
No.
Yes.
I thought I had something, but now I don't.
Algebra says I can multiply both sides by 1/8. This feels like you're a wizard, Larry. X dx and 1/8 du are the same thing. Whoa.
So you just like flip the u to -4 and the x just because you can, right?
Flipped what?
Like from x to negative.
I didn't flip anything. I noticed that I have two functions multiplied, and multiplication order does not matter.
Yeah.
Question? I'm just using the equal sign. X dx is exactly the same thing as 1/8
You know what,
du.
I said the other one was nasty, I think this one's gross.
You are correct. I was very tempted, but it felt like it would be too mean. That when you said this makes me ill, I was going to say just wait.
You know, you should have.
But I felt like it would be too cruel. So.
I would have laughed.
Okay. Are we good here?
Yeah.
Look, all eyes on me. Everybody look at me. Look at me. This is why I emphasize so heavily all year long. Equal doesn't mean, this becomes, equal means these are the same. And all we're doing is taking advantage of when things are the same to rearrange the problem to be more solvable. More useful. Look, I have three factors. 1, 2, 3. 3 things that are being multiplied. One of them is a constant. Therefore, the rule says that constant can be pulled out. That's why I say the 8 didn't matter. So it's going to come out anyway. 40 multiplied by 1/8 is 5. Look at your pink sheet.
Now we have like an x to the end.
Yep. It's like I said, you always finish the problem with the pink sheet.
Is there a point where we'll stop using u, or will we end with du?
Nope, stay with me. Is everybody okay to there? Last step is to say, well, I really was supposed to figure out the antiderivative using the variable x, so now I go back.
Do you put the, you put 4x squared minus 3 instead of u?
Yep. So now I have 5 multiply, stop that.
Just pound it back in it.
Nah, it doesn't help. And final thing, just put plus c,
On a written section, do you have to replace the u with it to get the credit?
Hold on. Here's why Jackie gets the ticket. It's really important to know when to stop. If all that's left is add, subtract, multiply, and divide, definitely stop. But the u substitution is a calculus concept, so they expect you to one more step.
Okay.
You wrote an arrow. How am I
Oh.
supposed to do that?
This is one place where I say it's okay to use the arrow. Totally agree. Hold on. It's because it's hard to read the board if I scroll, because I have to scroll up and down. So I'm just saying, carry the word forward. So I agree with you. I prefer to go straight down the page, but I do cheat there. You're right. Happens no.
So does the view just become one from your bottom?
Right here,
Yeah.
from here to, no, good question. Oh, look up, come on, everybody, look up. Look up. I think the easiest way to think of it is, when you're doing an integral, the du literally means a small change in number. Okay? When we're doing an antiderivative, the meaning slightly changes. Just think of it as you have two symbols, the big S and the du. And they're telling you, like parentheses kind of, they're telling you that what's in between needs to be anti-differentiated. So when you find the antiderivative, you don't need the symbols anymore. They're just there telling you what to do. So it doesn't become one. They just, like, we've done with it. Or you can think of it as the rule sheet says this is equivalent to this. It's not a very good answer, I can tell.
But like, where does it go? I don't.
It doesn't go anywhere. It's like this. Look
How
up.
if we have the d over dx and the measure?
Yeah, that would always work out. You can say dx over dx is 1.
But
It
this
doesn't
one,
quite work the same
they're
here.
small.
It's more like this. What goes here? Where did the plus go? You just used it, right?
Yeah.
Like you did what the plus said to do.
Or the parentheses.
Think of that. Think of this the same way. You are doing what these two symbols are specifying. When you've done it, you don't need the symbols anymore. Does that help? Or, I mean, we do it all the time, like this. Look. What do you write? 4. Where'd the root go?
Into the 4.
You just did what it meant, right?
Yeah.
It's the same thing here. These two symbols, you've done what they asked you to do. So we don't need, I'm not getting a really good answer, I totally get that. There just isn't a better explanation for our class. What's your point?
The S for the sum and the D for the antiderivative.
Yes, listen to Jackie. Hey, listen. Don't mix up the two. Look, come on, look. Integral, the big S means sum, means to add them up. With an antiderivative, because integrals and antiderivatives are connected, they use the same symbol, but the meaning is different. It's just telling you, find the antiderivative. Like, think backwards. That's all we're doing.
Okay, then.
Good enough for today? Okay.
Then how do we tell between when it wants us to integrate and when it wants us to antiderivative?
Limits.
Oh, I didn't even know.
Oh, okay. So,
That's what we're... Right? Like everything prior to today, we always have limits, right?
This is-
So limits,
this one is
integral.
unending.
What's that?
That's the function.
I don't think of it that way. I guess you do. I don't know. I've never thought
Like,
about
it
it.
just-
It just means antiderivative.
Because there's like a value to the x.
It just means antiderivative.
Anti-derivatives